So today's lecture is on deadlock, and let's see what is a deadlock. So deadlock is a condition where two or more processes sharing the same resources or they are preventing each other from accessing the resources. So this is known as deadlock. Okay. So an example of a deadlock can be like suppose two people are there and both are dialing each other at the same time. So what will happen? Neither of them will get the line. So this is known as a deadlock. Okay. Let's see some other example of deadlock. Another example of deadlock can be like suppose two trains are approaching each other at the crossing and both comes to a full stop and neither shall start until the other has gone. Okay, so this can be another example of deadlock. So we can take an example of a bridge crossing example. So in this bridge crossing example, there is a traffic only in one direction, and each section of a bridge can be viewed as a resources. So if there is a deadlock, okay, then it can be resolved only if the car goes back or the car will be preempted or roll back. Then only the other car could go through that bridge. Okay. So several cars may have to be backed up if the deadlock occurs, and there may be a problem of a starvation. Now starvation means an indefinite blocking, but it is not an infinite blocking. Okay, now let's see the difference between deadlock and starvation. So what is a deadlock and what is the starvation? We'll see the difference. Okay. Deadlock is a situation where two or more processes are blocked by each other. Okay. What happens over here is a process is holding a resources, okay, and it is also requesting other resources which is being held by some other process. That is known as deadlock. So what is a starvation? Now starvation is a situation where low priority process are getting blocked by the higher priority process. Okay. Next we'll see like deadlock is an infinite waiting. Okay. There is no time frame for that. But starvation is a long waiting but not infinite. Next we'll see that every deadlock is always a starvation, but every starvation is not a deadlock. The requested resources are blocked by the other process in case of deadlock, whereas in starvation the requested resources is continuously being used by the higher priority processes. So that is the difference. In deadlock, the process is being blocked by some other process, but in case of starvation, the processes are continuously being used by the higher priority processes. That is the difference. Okay. Now, in case of deadlock, there are some necessary conditions are there. That deadlock will happen if there is a mutual exclusion, hold and wait, no preemption, and circular wait occurs simultaneously. Okay. But in case of starvation, it occurs due to uncontrolled priority and resource management. Okay, like suppose a process is executing, and in the meantime some higher priority process arrive, so that will be preempted. Okay, so that is the difference between the deadlock and the starvation. Deadlock system model. In deadlock system model, the resources are represented in a form of R1 to Rm. So resources can be a CPU cycle, it can be a memory, or it can be an input and output devices. So each resources type Ri has a Wi instances. So each process utilizes a resource as follows. First you need to request, for example, using an open system call, then use that resource, and finally you need to release those resources using a closed system calls. Any instance of a resource type can be used to satisfy a request of that resources. Necessary conditions for deadlock. So these are the necessary conditions that must hold simultaneously for a deadlock to occur. So first is mutual exclusion condition, which means there is no sharing. Only one process can use resources at a time. Next is hold and wait condition. A process holding at least one resource is waiting to acquire additional resource which is currently held by the other processes. It means, suppose there is a process Pi is holding Ri resources and it is requesting for an R2 resources. So similarly, a process P2 is holding an R2 resources and requesting for an Ri resources. So this is known as hold and wait condition. The third one is no preemption condition. No preemption condition means a resource can be released only voluntarily by a process holding it after that process has completed its task. Next is circular wait condition. There exists a set P0 to Pn process such that P0 is waiting for a resource that is held by P1 and P1 is waiting for a resource that is held by P2. Similarly, Pn-1 is waiting for a resource that is held by Pn and Pn is waiting for a resource that is held by a P0. So this condition is known as circular wait condition, and these all are the four necessary conditions for deadlock.